Hello everyone, welcome back to this part 3 of Zoho IoT 101 webinar series where we will delve into building models, data flow and dashboards. Right. So we had part 1 and part 2 earlier. So part 1 was introduction to Zoho IoT and part 2 was connecting various types of devices with Zoho IoT platform. And today we will see about models, data flow and dashboards. A quick intro about myself to those who don't know. I am Jagan. I head Zoho IoT. I have been with Zoho for over 2 decades, primarily involved in product engineering, product management and customer implementations. And so this is the agenda for today's session. So first we will have a quick recap of what we had seen in part 1 and part 2, and then we will delve into models and instances, the concepts behind that, and then corresponding screens in Zoho IoT, and Datapoints message handler for handling custom messages, and alarms and commands, dashboards. So we'll have a question session in between as well, so you can feel free to stop us in between. So first, a quick recap here. So what do we offer? So we offer a powerful combination of IoT platform, a customizable platform, and vertical solutions that are targeted for enterprise businesses and industries, where this combination could accelerate the IoT deployments much faster than ever. And what kind of platform is this? Is a low-code, highly secure, enterprise-grade platform that comes with hundreds of devices support, and it can process and store billions of data points, and it can have a real-time visualization through dashboards and analytics, and it also has AI-powered analytics module, and it also has integrations with critical applications like CRM. Right. So, and these are all the portfolio of vertical IoT solutions that we focus. One is industrial IoT for smart manufacturing, but two, smart buildings and energy management for any type of facilities, and connected products for OEMs, which are targeted for manufacturers again, and point solutions like fleet management, fleet tracking, waste management, smart lighting, and a lot of other use cases. And in the part 2, we had seen some of the high level architecture, engineering architecture behind the platform, and also this summarizes some of the core modules. We can classify them as manageable entities. So they represent devices, IoT devices, the assets that we are managing, and also the spaces and the locations that belongs to. And you can also add custom modules on top of that and extend the application. And all these manageable entity modules has the monitoring and control capabilities within itself. So the data points, the alarms, commands, template, dashboards are all part of these devices, assets and locations. You can have defined these attributes on these modules, core management modules, and you can also add custom fields. Next one, we also looked into connecting devices and the user journey involved in the previous session. So where there are 3 major steps involved. One is adding a device, which is similar to getting a visa or booking a flight ticket, where we get an authorized ticket, which could be used to securely connect with the platform. And device onboarding involves several steps similar to how we arrive at airport and go through different procedure to onboard the flight. And also customizing the devices is all about after connecting and onboarding the device. So here we also looked into various types of the devices that you could add. You can broadly classify as gateways, peripheral devices, smart sensors, which could be LoRa or Bluetooth or any of these Wi-Fi devices and things. And we also looked into device onboarding assistant. This is onboarding steps that seamlessly help the developers to go through these stages one by one, so that you can do every single step following these procedures. and successfully onboard your device. So with that, we ended the part 2, and now in this session we'll start with models and instances. So models are think like they are blueprint house kind of a design through which you can build multiple similar type of houses. So in the context of the house design, where you would have definitions about the number of the rooms, the layout, the front view dimension, top view dimension, and things like that. And the individual houses will inherit those structural layouts and dimensions and things, and they can even have unique colors and things over and above the the structural basic fundamental layouts. So similar to that, we represent device models under devices module. So for example, energy meter device model can represent multi-vendor energy meters that are going to be deployed at multiple locations. So you can have all the common definitions under this energy meter device model, and all these instances of the energy meter would inherit the properties of that, and seamlessly you can manage them through that way. So similarly, you can look into IAQ, the indoor air quality sensor model, and things like that. Similarly, if in case of assets, you can see them as a chiller model, and say chiller is a critical asset, and through which you can have multiple chillers and corresponding data points inside that. Similarly, diesel generators and other assets. So so on and so forth. You can have that for location and things. And we provide a flexible way of creating the model. So one is seamless way. In the last session also we saw, while adding a device, there was a field named model name. You just had to enter that model name, and we proceeded with adding an instance, right? So behind the scenes, the model gets created and updated on the fly. So this way of creating the model by adding an instance and defining that instance, adding the other dimensions of the instance, will also go and reflect on the model information, so that the next instance when you add, you don't have to repeat that thing that what you had done in the first instance addition. So this is one way. The other way of doing is first start with model definition in developer portal, define them clearly, and then go ahead and then add instance. You can do either way, right? So what does this model have? So this has a collection of templates of configuration that gets copied when an instance created. So it has fields, it has relationship definitions, data point template definitions, command template, alarm rules, model settings are there, field settings are there. So it has message handler. So all these are defined as part of a model, so that it gets replicated for every instance. So before going to the next topic, so we will quickly have a look into the model and the instances. So this is the developer portal information page that we had seen in the earlier sessions as well. So under model workspace, you can find device models, asset models, location models, and custom modules and things. So this is the workspace that enables developers to define all and customize these models as well. For example, when you go into something like our air cooled chiller, so this model has several data point definitions, it has commands, it has alarm rules, it has relationships within it, and data point definitions and things like that. So we will delve into this section later. So this is high level asset model, and similarly when you go into the end application, these are all the instances corresponding to that. So for simplification purpose, we automatically create custom views based on every model. So you can see a list of all assets under the assets tab, and you can also find the model specific names over here, and these are automatically created. So for example, this tower air cooled chiller, so this has several instances corresponding with it, all inheriting the properties from the model. So with that, we'll enter into the next part, which is data points. The next one is the data points. So in data points, there are broadly you can have a real-time data point and scheduled KPI data point. And these real-time data points are some of the individual measurements or values that we collect from the data sensors at a specific point of time, and we also store them in a time series way. And the scheduled data points are something that gets called during specific time slots or periodic time intervals, like one hour once or a daily once or sort of thing, and where we define derived values from the real-time data points. So here, while adding the data point, there are multiple ways. One way is you don't have to define the data point actually, because there are products already listed out in the product gallery. So when you select the product and add those product using that way, the data points gets inherited from the product definition. So you're not adding essentially a data point there. There are other ways also over and above that. If you want to add new data points, custom data points, there are other ways where one is importing from a data point group. So we have a predefined data point list in the data point groups, and that simplifies the developers not to enter the names, the data types, corresponding icons, units and things. These are all pre-filled, and you can just import from that list. And custom data points is something you can start from the scratch. You can define their names, data type, everything. So that is the difference between them. And regarding the data point groups, they are there as part of the device addition flow itself. You can choose from the existing data point group, and then it will list all the data points. For example, it may have environment monitoring, a geo position, orientation monitoring, energy monitoring, all those data point groups, and you can pick and choose from there. This is also available from the model, meaning the developer portal space under model section. So coming to the data point configurations, these are some of the fundamental configuration elements that we need to understand while we define that. So number one is parsing key. So that defines the expression of converting the payload message into a particular data point value. Right. So first of all, the usual standard format of sending payload message to IoT is in JSON structure. So we have default parsing rules defined for those JSON structures. So the JSON will have a key value pairs, and also it will have hierarchical information representing assets or their pods or anything like that. So for that we have parsing key mechanism. So for example, you can have a gateway sending information about multiple conference rooms and corresponding environment conditions, or it could basically, the gateway can send information about multiple energy meters, and where the energy meters will have unique identifiers like EM1 or conference room 1, CR1, like that. So to reduce the payload band, meaning the size of the payload. So these are unique identifiers for those peripheral devices or assets or something like that, and we call them as edge key. So they are since they are identifying those unique elements of the peripheral devices, we call them as edge key. And using that, you can define expressions like edge key dot temperature, so that this becomes a placeholder when you are adding several number of peripheral devices in the application. So let's quickly have a look at the product. So for example, this one is the gateway page, and this one is an energy meter. So this energy meter is associated or connected through that particular gateway, test gateway, right? So this is the connected gateway through this lookup relationship. Once this system relation is done, the test gateway, so this can send the information about multiple assets and peripheral devices that are connected to it, right? So for this particular example, we can see try to connect this through a simulator. For example, we have already predefined the configuration, MQTT credential configurations of this particular gateway. So I'll go ahead and then connect it. So you can, on the left side, you can find that the status have changed to connected. So in real time, and now I'll start to listen for this particular topic, which is telemetry topic, and I go ahead and then publish this message from this equivalent to a device, right? So a gateway. So there is an energy meter 1, EM1, and the corresponding data point values. So I go ahead and publish this. So you can find that this particular JSON message has been received here. And so once this message is received, so what happens here is we have defined the data points under energy meters, right? So these data points are having this parsing key like edge key dot L1 current, like that. So if you go ahead and then edit them, you can find this parsing key mentioned over here. So there are various ways to define the parsing key, and we have also explained the corresponding structure, JSON structure, in what case what kind of key has to be fed in. So it can be plain temperature string, or it can be, since this is sent from a particular gateway which is aggregating and sending devices data, so we use a placeholder like edge key and then sending that. So here what will happen is the edge key will be replaced with EM1 and then will be stored. And you can ask the question, where is this EM1 defined as part of the energy meter? So that is defined as part of the details meta information. So you can find under details, there is EM1. So this is a configurable text information. You can change that if the value has to be changed. You can change from here. So once this is defined, you can now go ahead and then start seeing this data getting streamed in real time once the data is sent. For example, we have so far sent this information. I'm just changing the data to 80. So behind the scenes now, this automatically gets, the message goes to the device gateway and then gets parsed on that energy meter, and it's visualized from the data explorer. So this is the data flow for and the parsing mechanism that we have defined. So there are other ways as well, like there is a find val for different JSON structures where we have different types of expressions that we have given detailed in documentation. So this is the section where you can find all the list of the data points and the corresponding live, raw, and aggregated data points information. The next section is message enrichment. So even though we have a no-code type of data point parser functionality, it may not be sufficient to address this through this data point parser in all scenarios. In a few scenarios, you can expect that the data that is being ingested will have a message that needs transformation to make that understandable or to make that parsable, easily parsable. So for that, we have a couple of mechanisms. So one is message formatter. So message formatter is a way where this is applicable for LoRa devices. So for LoRa sensors, these type of sensors send the data as compact binary messages as byte arrays, and these needs to be decoded and converted as JSON structure first before we are able to understand, parse it. So the first stage for LoRa device would be that message formatter. So for the supported products that you see in our product gallery, we already have predefined message formatters. For some use cases, you can also go ahead and then write the custom message formatter. So that is an area where we open up a JavaScript editor where you can write the code for that. And then the next stage is message handler. So this is the section where you can transform the incoming message into a more kind of a parsable message, or you can even take multiple actions over here. So you can derive much more data point values from there, such as if there is a kind of a value that you want to compare from the previous value and convert that as a data point. So you could do all such transformation from this layer. So we can quickly have a look into these message formatters and handlers. So these are accessible from the device instance page itself. Under actions you can see message formatter and message handler. So I'll just go ahead and then show that quickly. Just a minute. Yeah. So this is the place where you find a message formatter and message handler. So as I mentioned, this message formatter is applicable only for LoRa devices. So I'll take a LoRa device and corresponding message formatter. This is a MileSite LoRa device, and you can see there is this is the custom message formatter code that we have defined for AM103 device. So this sends the data as a byte array, and this byte array is not user readable kind of string format that requires further streaming, understanding the byte and converting that as a. So you can also save and test here. So here, for the sake of understanding, I have given a hard-coded byte array string so that you can find when this particular byte array is received, what would be the output. So here this particular byte array would be converted as temperature and the corresponding value, humidity and battery. So these are essential for understanding and parsing the data point strings. The next layer is the message handler, as I was mentioning. So this is the next layer where when you create a particular device, message handler, we will give a skeleton code for you. So what is going to be the argument and what is going to be the header and things. These are arguments. And in this particular example, what we are doing is converting incoming temperature value from Celsius to Fahrenheit. However, why we are not doing from the data points section and going from here is this allows you to define conditional statements, like something like the data can be sent from two different ways. So one device probably may send in a particular format, and so I just go ahead with this. So when I'm sending this with decoded data as a string, so then it picks from that string and then converts into temperature in Fahrenheit. Similarly, the same decoder can be used for LNS device, so from the LoRa network server. So in that case, assume the data is sent from LNS decoded data as a different key. So in that case, you can normalize this JSON through the message handler. So the other ways of converting this are from the data point section as such itself. So for example, the data point section itself has some of these computational logic. For example, you can find this place where there is energy consumed. So this provides an option to do computation. You can switch on this computation and you can find a formula builder. So where you can find active energy minus previous value sort of things. You can build expressions, and the platform by default without any coding can do all these operations. So similarly, in the scheduled data points also you can come out with derived values, something like this. For example, in a solar monitoring use case, a performance ratio could be an important KPI scheduled data point. So this allows you to define data points and aggregation functions as well. So for example, this gets called every day, and it does the summation of the active power delivered data for today. So you can find these things by selecting and then building these expressions. So similarly, you can also have aggregated another field information or a data point information and time aggregated information, use multiplication, division, all these symbols, and also you can have final expressions like A divided by B into C into D. So this gives a ratio, and call this as a performance ratio in the solar monitoring world. So these are different ways of defining the data points, and also the by defining custom message handlers. So the next section would be the alarm rules. So alarm rules defines the criteria where we do proactive monitoring first of all, and through that you define a criteria through which we identify is there a kind of an abnormal condition or any critical condition from the application in the device or an asset or any of the manageable entity. So this is an extension from the previous data flow that we had seen. So there was a data point parser, and it shared the data to the big data storage and live notifications, and then the next topology is alarm rules, and through which we create, once the alarm rules paused, the threshold condition, alarms gets created or updated, and there are also a historical alarm information, and there are alarm actions that are triggered when you define those things: email notification, custom function, webhook, execute command, and push notifications to mobile apps. So let's quickly see what are the types of the alarms. Similar to data points, there are real-time data point based alarm rules. Similarly, scheduled KPI data point based alarm rules. Okay, so and inside an alarm rule, we have a few configurations. One is state. State is a customizable label or a string that actually defines the current state of the machine or asset. So for example, it could be in a battery scenario, it could be fully charged, or low charge, no battery kind of use case. In a temperature use case would be high temperature, normal temperature, low temperature. So these are all a translation of those physical, meaning the numerical readings into human readable texts, right? So that you can take quick actions and response. And severity is a standardized label, so where we predefine with names like critical, major, minor, warning, clear kind of thing, so that you can map those states to these predefined standard severities, so that you can have a prioritization of go and fix all the critical alarms sort of thing. And occurrence condition is a criteria that we define whether you need to take actions or create an alert for some transient fluctuation. So it's a temporary spikes that are happening. For that, do you really need an alarm to be created, or you need to validate whether there is a persistent kind of problem in the application or the device, and then find out the stability of that condition and then create an alarm. So we have this inbuilt criteria builder for occurrence creation, so that you won't have to overwhelm the users with creating too many alarms, repeated alarms sort of things. And active time period is something you can define for only on these time period. If there is a threshold breach, you need to create an alert. On other non-business hours, you don't have to create. Similarly, noise reduction is also a functionality to not to create or update alarms unnecessarily for repeated same states. And so here actions are something that you can, as I mentioned, there are multiple actions that you can define, and there is also advanced state transition based actions where you can execute these actions only when a state is transitioned from clear to major, not from critical to major. So it is not something always that a major state requires a particular action. So for that kind of advanced kind of use cases, you can define state transition based actions. And as part of the alarm rule definitions, we have a flow where you can define the condition, configure the message, and configure these actions. So with that, we can quickly see one of the alarm rule. So take this alarm rule information. So this room temperature alert, you can find normal room temperature, and then high room temperature, low room temperature. So for easier simple purposes, we can see that room temperature is between this. You can also edit this. So room temperature, you can have different operators and you can have multiple values over here in this, and you can also have string values or any data point values could be used over here to compare the information. So there is occurrence condition. When you are switching on, you would be asked to fill in how do you want to validate this, occurrence by count or occurrence by period or occurrence by period and count both together. So we essentially do the noise reduction. So similarly, you can also have custom alarm messages. You can use a hash and then use the placeholders, like the data point values and things can be printed from here. And also you can have different actions, email notification and things. So these notifications can also be defined as template and reused for other purposes. So next we will move on to commands. So commands are a set of instructions that we send from the cloud to the device to perform any action, right? So something like you want to switch on off a light or asset, and you want to control the temperature through a slider. You want to change the mode of operation by pausing on the pick from the pick list, or it could be a custom button action as well. So these are different variations of input types for the commands. Similar to a parsing key in data point, we have a command key. This defines the JSON structure that will be sent from the cloud to the device. So you can find out that a command key is a JSON structure. So you can pass on unique values, something like if you want to control your portico light, or you want to control your kitchen light, there could be unique strings that defines those lights, so that you can take control from the edge application to take actions on that. Similar to data point message handler, we do have command message handlers. You can convert the messages that are sent from the cloud to the edge, and you can transform that message so that if there are any third-party devices that requires in a specific format, you can transform this JSON structure to that using the message formatter or handler. There are command timeouts that are there. So these are some of those inputs that we could give, and for successful command acknowledgement, so we have predefined status codes. Once after you execute that on the device side, we expect that the edge should send in a particular format, where 1001 means execution success, like that. So we can see a quick example as well. So for example, we have a command configuration from this gateway. So there is a lights on off kind of a situation here. So if we proceed, you can select that and execute it. Just a minute. Reloading it. So I'm just going to the command. So now I'm selecting and then executing it. So you can find that lights on off kind of thing. So what you could do is, on the device side, there will be a separate topic that you need to listen for that. So we have already subscribed to that topic. So any incoming message that is being sent will be seen over here. So you can see this is the key that the JSON structure, it will send this while executing that. So while you receive this message, you can take corresponding actions. Say something like in Arduino use case, for example, you get a command message and you see what action needs to be performed using that received messages. So you can do a digital write on the relay pin to switch on the light on. So these are the code that you usually develop on the edge side to perform these kind of actions, right? So here, in order to make this as success, we need to execute it again, and you will get a corresponding, key. So this is the key for which you need to send a response. So just just a minute. So this is the acknowledgement format that we expect to send to the application. So for example, this is still in progress. Okay, executing it again. So here you will see correlation ID. So for this same ID, you need to send the response back, so that you can now see that the command would get, this is reconnecting and connecting. So underneath, so this is the way where you will send the response back to the command to see that the command gets successfully executed. So there are also execution history you can find from here. So what are the times it has been executed, whether it was successful or not, something like that. The next section is the fields and the lookup relationships. So you know that you can define multiple metadata information as fields. So we have custom fields for that purpose, and a field builder for that. So this is similar to Zoho CRM or Creator, where we provide a custom drag and droppable field builder, where you can drag a single line, multi-line, a pick list, checkbox, numerical, decimal, section, new sections, and all things, a date field. And you can also create lookup relations between one module to another module. So this enables you to set up relationships, custom relationships between multiple assets or devices. For example, if you want to have a car, and then you want to also have tires and engine modeled as different assets, sub assets, which are children for that, and you want to track the data points from that asset. So you can define these sort of relationships through lookup relationships. So this is not limited just for asset relationship. You can totally create custom modules like an inspection process. So something where you want to get a lot of manual inputs for an inspection, and you want to look up a particular machine which has this asset information. So this module will have a relation, this inspection module can have a relationship with the existing asset or a device module. So the field builder, so this is something available as part of this place. So under model, you can find fields and edit form layout. So this is a place where you will drag and drop and create a lot of custom fields. These are predefined fields, and you can even remove these fields, and you can find a gallery of fields. You can reuse some of these fields as well, instead of going ahead and then recreating them. Okay. The next section would be dashboards. So this is the place where the data gets the life, right? So where we were able to visualize the data in the way that we want to see. So as part of this dashboard visualization, we provide various types for various purposes. So one is template overview dashboard. This is something you can have a specific dashboard view for every instance. For example, every energy meter, when you want to enter into that page, you want to see that a kind of a specific view, or every chiller instance that should have a specific dashboard view, so that you can see the right information in a single glance. So for that purpose, we allow you to create template overview dashboard from the model level. So once you define that all the instances will inherit from that. So we also provide an option to override that option. So from the model part. So where you can define instance specific overview dashboards as well. So the next section is the global dashboards. This is an area where you define dashboard elements to have a mashup of information across all modules, right? So any module, so it could be one from the device module, one could from the asset module, and have a consolidated information. So, and we also provide global time filters so that you don't have to change the time value for every single widget. Globally there will be one time filter. If you just change that, all the widgets that you see inside the dashboard will update according to that time rule. So similarly, there is one more type of dashboard, which is model aggregation dashboard. So this allows users to aggregate within a model. So you can have something like you want to have, say, I'll show an example. So this is a place where you want to have model aggregation, like want to have list of all the bikes and the corresponding metrics. You want to compare them, or you want to have an aggregated what is the total distance traveled by the bikes, and you can also filter out based on a particular sub classification of the bike. So where the product name is bike premium 500 watts. So for that bike, if you select, there could be 10 bikes corresponding to that model, so you can find a consolidated filtered view for that. So that is the third category of dashboard. So we can also look into, so this is the place where you see all the global dashboards. So the user experience in creating these three types of dashboards are similar. There are no single dashboard, but only the filtering rules and things are applied on top of that. So this is a place where you define the dashboard and the widgets. We provide a catalog of widgets. So there are card widgets, there are chart widgets, custom fill dials, the other things, right? So for example, when you see this particular bar chart, so you can find the primary module here we have selected is building, which is a location module, and this has multiple data points, and the corresponding the units are filled. You can also change the units, and you can apply the aggregation functions over here, maximum, sum, and last value, first value, and corresponding colors. And you can also group that by a field property. So that is the high level category that you can see. This has instance property grouping or time grouping. So here this has a instance field property grouping. And so we'll also have other advanced things like ranking based on a particular data point value. Also add a threshold line. You can define the value for that, define a color rule, and you can also define the bar colors for that. So once you define that, you get to see all the list of the buildings by names, meaning buildings values, the max demand value by their names, and we also see that these two buildings has breached that threshold that we had given for the max demand. So similarly, you can see this for every single chart type of widget. So this is a line chart widget. You can find out energy meter, the energy consumption value, their aggregation value. So the thresholds defined over here. So this is a dial. So in this is using the particular occupancy count. So we show all the occupancy information, and you can define the ranges for the thing, and also you can define a target value as well. These are different sorts of cards that you can define from here, and these are custom views that you can embed inside the dashboard view itself. This is a donut view that you can configure. This is a calendar based heat map view. You can define color rules and things from here. So all these widgets are easily customizable, and this is a Sankey diagram view, which enables you to represent the distribution of the data of through different entities. So, and this one is energy consumption, hourly or daily based heat map. You can have settings, and you can also control them to find out what is the peak usage period. Is there a kind of a trend that you see for that in a particular area? So similarly, you can go ahead and then add image card widgets. There are table widgets, calendar widgets, timeline widgets are there, the image time layout widget. So these are something like this. So you can use a background image, and you can overlay the live data information on top of it. You can choose on this STP plan what are the data points that I want to overlay. Once this is all defined, you can have a drag and droppable code, so where this contextualize that information, where you can see a real-time data information near to a pump, instead of seeing them in typical list views or any bar charts and things. This has an intuitive way where we have the right context in near to the place. So there are other map widgets as well, geographical map widgets. So there are widgets that has a custom fill, something like a tank level monitoring use case and things like that. So we have summarized all the types of the widgets from here. So you can have all these sort of widgets, and this is anyway we are adding up more widgets as we go. And so these are the types that we had seen, like historical widget or real-time widget, right? So time grouping or things. So that takes to the end of this presentation.